Ever wondered what lies beyond the observable universe? The cosmos is a vast, mysterious expanse that has fascinated humans since time immemorial. As we delve deeper into the cosmic abyss, we encounter enigmatic phenomena that challenge our understanding of the universe and its workings. One of the most perplexing of these is dark matter. Invisible to our telescopes, dark matter doesn't emit or absorb light, yet it comprises about 85% of the universe's total matter. Scientists theorize its existence because of the gravitational effects it appears to exert on galaxies. But what exactly is dark matter? This question remains one of the most significant unsolved mysteries in cosmology. Then there's dark energy, a hypothetical form of energy that permeates all of space and is believed to be the driving force behind the accelerating expansion of the universe. But what makes up this dark energy? Is it a property of space itself, or is it a new kind of particle we've yet to discover? The answers remain elusive. On a similar note, our understanding of the universe's workings is currently split between two theories. Quantum mechanics, which explains the behavior of particles on the smallest scales, and general relativity, which describes gravity and the large-scale structure of the universe. Both theories have been extremely successful in their respective realms, but they contradict each other in certain situations, indicating that a more fundamental theory is needed to unify them. This quest for a unified theory is one of the greatest challenges in theoretical physics. Finally, we have the question of the universe's size and nature. Is the universe finite or infinite? What lies beyond the observable universe? Is our universe just one among an infinite number of universes in a multiverse? These questions push the boundaries of our understanding and challenge us to redefine our place within the cosmos. As we gaze into the cosmos, we realize the enormity of our ignorance. Each discovery only leads to more questions, more mysteries to unravel. But in our relentless pursuit of knowledge, we continue to probe deeper, ever hopeful that the answers to these cosmic mysteries lie just beyond the next frontier. How does the brain, a network of neurons, give rise to consciousness? This question remains one of the most captivating enigmas in biology and medicine. Consciousness, the very essence of our being, is a remarkable phenomenon. Yet its fundamental nature and its origins within the complex labyrinth of the human brain remain largely elusive. Is it a byproduct of neural activities or something more profound, an entity yet to be understood? Moving on, we delve into the mysteries of aging. It's a universal truth that all living organisms age, but why? What are the mechanisms behind this inevitable process? Is it the result of accumulated cellular damage or a predetermined biological clock ticking away in our cells? And the next big question, can we reverse it? If we can understand the nuts and bolts of aging, we might be able to slow it down or even turn back the hands of time. Now let's shift our focus to some of the most complex diseases known to mankind: cancer, Alzheimer's, and autoimmune diseases. These illnesses are like intricate puzzles, each piece representing a different facet of the disease: genetics, environment, lifestyle, and more. Despite decades of research, we are still working to put these pieces together to form a complete picture. Can we find a definitive cure for these diseases? Or are we looking at personalizing treatments based on individual genetic makeup and environment? Each question leads us further into the vast expanse of our ignorance, but it's this very ignorance that fuels our curiosity, propels our research, and drives our progress. The human body, in all its complexity, continues to baffle and bewitch us. It's a biological masterpiece that we're just beginning to understand. Yet with every new discovery, we realize there's so much more we don't know. While we've made remarkable strides in our understanding, the human body still holds many secrets. Every day we're pushing the boundaries of our knowledge, inching closer to the answers. And perhaps one day we might just solve these biological enigmas and medical puzzles. What is at the heart of everything? Is there a theory of everything? Dive with me into the unresolved mysteries of physics and chemistry. Scientists have been striving to discover a theory of everything, a single, all-encompassing, coherent theoretical framework of physics that fully explains and links together all physical aspects of the universe. Yet it remains elusive, a beacon in the distance. Then there's the enigma of high-temperature superconductivity and superfluidity. How do certain materials conduct electricity with zero resistance or flow without friction at high temperatures? It's a riddle wrapped in a scientific enigma, and let's not forget the proton radius puzzle. The proton, a fundamental particle in the universe, has been measured to have different sizes under different experimental conditions. Why is this so? The answer is still up in the air. The fundamental workings of our universe continue to puzzle the brightest minds. And with every answer comes a new question, keeping the pursuit of knowledge forever exciting. Can we predict, or better yet, prevent natural disasters like earthquakes? This question resonates with us all, as the earth beneath our feet is more mysterious than we often consider. Earthquakes, for instance, remain largely unpredictable. Despite advances in seismology, the exact timing and magnitude of these natural disasters elude our grasp. Then there's the colossal challenge of climate change. Scientists worldwide are striving to understand to what extent we can reverse its impacts. The answers are complex and involve intricate interplays between technology, policy, and human behavior. One of the most fascinating yet complex aspects of our planet involves the long-term cycles of Earth's climate. These cycles, spanning over tens of thousands of years, interact with our own anthropogenic effects in ways that we are only beginning to understand. The more we learn, the more questions arise, forming an endless cycle of scientific inquiry. Our home planet Earth remains a mystery in many ways. What drives inequality, and can we create a fairer world? This question plagues sociologists and economists alike. A myriad of factors contribute to systemic inequality, from historical disadvantages to structural biases. However, the exact root causes remain unclear, and their resolution even more so. On the economic front, we grapple with the challenge of balancing growth and equality. Is it possible to design an economic system that fosters both? The answer to this question is as elusive as the problem itself. In the age of rapid technological advancements, new conundrums arise. The impact of these advancements on job markets and social structures is a topic of intense scrutiny. Will technology liberate us from mundane tasks, or will it render us obsolete? These are just a few of the conundrums that we face in sociology and economics. Remember, societies and economies are complex systems with many unknown variables. Can machines ever match or even surpass human intelligence? This question has been at the forefront of the technological world for decades. The concept of artificial general intelligence, or AGI, is one that both excites and terrifies. AGI refers to a type of artificial intelligence that has the ability to understand, learn, and apply knowledge across a wide range of tasks. Much like a human, it's a fascinating concept, but the path to achieving it is shrouded in mystery. Quantum computing, another emerging technology, is equally intriguing. Its potential to process information at an unprecedented speed could revolutionize industries and redefine cybersecurity. But the mechanics of quantum computing are complex and not yet fully understood. These technological unknowns and AI uncertainties highlight the dynamic nature of our world. As we push the boundaries of what we know, we're confronted with new questions and challenges. The future of technology and AI is exciting but filled with uncertainties. Are there problems in mathematics that are truly unsolvable? This is a question that has perplexed mathematicians for centuries, leading us to the concept of Gödel's incompleteness theorems. These theorems suggest that within any self-consistent mathematical system, there will always be statements that cannot be proven or disproven. A humbling thought for those of us who like to believe in the absolute certainty of math. Shifting gears, let's delve into the realm of philosophy. Here we grapple with abstract concepts like morality and free will. The fundamental principles of morality vary across cultures and ethical systems, creating a rich tapestry of beliefs about what is right and wrong. And then there's the debate on free will. Is it an illusion, a mere product of our brain's complex machinations, or does it truly exist, giving us agency over our actions and decisions? Mathematics and philosophy push the boundaries of our understanding. What is the origin of language, and are we alone in the universe? These questions ignite the human imagination as we delve into the complexities of communication and the vastness of space exploration. Language, a uniquely human trait, remains shrouded in mystery. We wonder how it evolved, how it transformed from primitive grunts to the eloquent expressions we use today. And the complexities of human communication extend beyond mere words. The subtleties of nonverbal cues, the nuances of cultural context, all contribute to this intricate dance of interaction. Now let's turn our gaze skywards. The cosmos, a canvas of infinite possibilities, beckons us with a tantalizing question. Is there other intelligent life out there? As we probe the universe, we're not only looking for extraterrestrial life, but also exploring what it would take for humans to inhabit other planets. From our own communication to the potential for interstellar conversation, the unknowns are infinite. In every field of study, we are confronted with more questions than answers. Our journey through cosmic mysteries, biological enigmas, and technological unknowns exposes the vastness of our ignorance. From the microscopic to the cosmic, from the nature of consciousness to the origins of language, we're reminded how much remains to be discovered. As we grapple with societal dilemmas, environmental uncertainties, and mathematical conundrums, our pursuit of knowledge remains relentless. As we continue to explore, we realize that the greatest knowledge is knowing that we know so little.